Good evening, millennials. Today we'll be looking at another LeetCode problem often asked in FAANG interviews such as Amazon and Google. So this is the 139th problem in the LeetCode website called wordBreak. So let's read the question and try to write the shortest code possible. So the question is, given a string s and a dictionary of strings wordDict, return true if s can be segmented into a space separated sequence of one or more dictionary words. Okay, note, the same word in the dictionary may be reused multiple times in the segmentation. Let's look at the examples to understand this note and the question. So we are given a string s, say LeetCode, and we are given a wordDict, which is an array of strings leet and code. We have to return true as LeetCode can be split as leet and code, and this is possible, and these two words exist in the wordDict. The second example, we have a string called applepenapple, and the word dictionary is apple and pen. It's again true because applepenapple can be segmented as applepenapple, and we are allowed to reuse a dictionary word apple. However, catsandog is given and with only one D, and word dictionary is cats, dogs, sand and cat, but still we can't divide it into like two or more words such that the strings are available in the word dictionary. Suppose you split it as cats and OG does not exist, but if you split it as cats and dog and does not exist, so the output is false. So let's look at the constraints. The constraints is that the string length is between 300, okay, and the word dictionary dot length is within 1000. So you can use an n square algorithm, and word dictionary, and each of the words in the word dictionary is between 1 and 20. And also it's given that s and word dictionary of I consists of only lowercase English letters, and all the strings of word dictionary are unique, so you don't need to search for duplicates, or you don't need to eliminate duplicates if the vector string word dictionary contains the if it contains any duplicates. So let's look at the coding approach. So let's take this example. So we will know that this exists in the dictionary if we split it here and here. So what we need to do is, once we split on the basis of apple and penapple, we need to update the position such that if the previous word exists in the word dictionary and the remaining words can exist in the word dictionary, we just have a DP array here and we update that position as true. So we can have a DP array of size n, where n is the length of the string, and we can, depending on the split, we can update the DP array saying whether we can find the word or not. So this will work because when we check here, we will find the DP array of apple exists, so we will update this as true, and when we come here we can again find the DP array of pen exists, and again the DP array of apple exists, so overall we will get the answer as true. So this is a simple dynamic programming problem. So let's try to write the code for this. So first I'll declare the integer n, which is the size of the string. Then I declare a boolean vector array, since the return type is boolean, vector bool dp array of size n plus 1, because it's an n letter word and we have to return the nth dp. We have to return whether it's possible to split an n letter word, and initially I initialize it all as false. When the word length is 0, we know that it can be formed without any word in the word dictionary, so this part is true. And at last, once we compute the DP array, we need to return DP of n. So let's write the loop. For int I equal to 1, I less than or equal to n, plus plus I. So I am just iterating through the string, and so we have to split the string, right? So for int j equal to 0, j less than I. So what I'm doing is I'm just finding the substring till that string. So if when I is 5, this will be the j, and I can calculate the remaining string as I minus j. J less than I plus plus j. So what I'm doing is, if dp of j is true, so I can just write dp of j, which means that this word exists. Now I have to find whether this word also exists in the dictionary. So I can just write an inbuilt function, find of word dictionary dot begin wordDict dot end, and the third argument will be my substring. So s dot a substring of, from j we need to pass till I minus j. So that is the substring up till this point. So till here to here, that is the substring we are calculating, whether it's in the DP array or not. So when I come here, I will have apple, and then I will check for pen is in the word dictionary or not. So the syntax is find should not be equal to wordDict dot end. So depending on the language this might vary, but in C++ it gives a simple pointer. So I just check whether this word and this word exists in the dictionary, then I update the DP at this point. Again, when I come to the DP at this point, we know that the DP of this will exist because we already know one split, which is apple and pen. So similarly you can find for this and the remaining things, because this will come till j to I. So at last you know at least one possible combination exists. So if this dp of j is true, which means the first part is true, and when we check for the remaining part, which is from j to I minus j, so this string, it will not be equal to wordDict dot end means it exists in the vector wordDict. That means I just update my dp of I, which means I found a combination, so I can just break from this loop. And at last I return the dp of n, which means that there exists at least one combination. So depending on whether there is a possible solution or not, dp of n will be true if it has been updated in the last iteration, or false, which was assigned to it in the initial stage. So let me just run the code. So this works for this case. I've just ran it a few times to prevent any overflow errors. As you can see, this is the shortest code and it passes. If you can find a more shorter or more efficient approach, please leave it down in the comments below and we will try to update it or invite you to our channel. Thank you.